Loops. Okay, so today we're going to look at how we can make use of loops within Solidity. A loop is a way for us to iterate over an array, a list of some sort, and maybe retrieve some data. As with many programming languages, Solidity also provides us with a for loop, a do-while loop, and a while loop. Now, I have to start off by saying that using loops in your code could be very costly, especially cost a lot of gas to do the operations, so use them sparingly. Looking at the code in front of us, this is our pizza contract, and a nice use case for a loop in here would maybe be to create a function that can return to us all the orders that has not been delivered yet. So let's create this function. Let's start off by making some space for a new function. This function name is very long but yet descriptive. It says orders that needs to be delivered. Now this is perfectly fine, and we're going to make this a public function. We are also going to return something. Now, after looping over all the orders and trying to get the ones that still needs to be delivered, we are essentially going to return the entire order itself. So this struct. So over here we can say this will return to us a list of orders. So we're going to say orders array, like so. But let's think about this carefully. So even though we want the full order over here, there's no way for us to identify that because that lives in the orders mapping. So instead, what would make more sense is if we return an unsigned integer array. And whenever we are dealing with arrays and structs, remember, we need to specify what memory allocation or storage allocation we're going to use. In this case, I'm going to use memory. So the first thing that I would like to create is a temp variable. This variable will be of type uint, and it's an array of uint. We need to specify that this is memory. And then for the name, I'm just going to say that these are going to be my temp orders, which we are going to use to populate. And then right here at the very end, we are simply going to return the temp orders. Now, currently, we are going to return this, and essentially nothing is happening because we have these temp orders, which is empty, and we're simply returning them. So in the middle here, we need to find a way to kind of identify which order still needs to be delivered, right? So we now have two options. We can use a while loop or a for loop for this. Let's first look at the while loop. To use the while loop, we first need to define a number that's going to act as a counter, and I'm going to specify this as a uint I, and I'm going to equal this as 1. Then right after this, I'm going to write the keyword while, and it's going to take in a condition. Now this condition should ask if I is less or equal to the order count that we have up here. And we are referring to this I. So imagine the order count being 3. I is less or equal to order count. Then we are going to execute this code. And you can see in this loop example, it will continue forever unless we increase I incrementally in this while loop. And in this case, our contract will fail and run forever, so we don't want that. So instead, what we could do is say that at some point in the while loop at the very end, we would like to increment I, and this is this parameter. So eventually, this will catch up with order count and will stop execution. Now in here, we get to add to our temp orders. So let me add the code and explain. Here it is. Essentially, we have an if statement and we are checking our orders. So these are the mapping. So we are checking the orders and the order I, the current iteration where our counter is at, and if this order is delivered. Now we are essentially saying not here in the front. So technically we are saying if this order is not delivered, run this code over here. Now, as we can see, we clearly have an error, and this is because we cannot use the push method, which we are trying to use here, inside of this function because we are using memory. We can, however, use push if we made this storage and made it a part of the storage of the contract. However, that is a bit gas intensive, and there's a better way of doing this. So, to rectify this, we are actually going to say this will be a new int array, and this will actually be a fixed size array. And we know that all the orders, well, the actual undelivered orders will not be more than our order count. So that's what we're going to start off with. We're going to have a fixed array that's going to allow us to have all this space. Then we'll need an extra parameter, and this will be our count. We're going to set this to 0 at first. And instead of using push, we are simply going to index the count and equal this to I. And right after this, if we found an order that still needs to be delivered, we're going to increment our count. But now we'll be left with a temp orders, which will be very big because we have all this extra padded space. So we could either leave it like this or essentially reduce the array as well. And I am going to do that by using a for loop to reduce this temp orders. But before we do that, let me just show you the results of this function by deploying the contract. And now we are going to add one ether here at the top, and we're going to place an order. We're going to add another one, place another order, and let's do 3. So 3 orders have been placed. We can check that an order is there, and all of them have not been delivered. So actually, let me deliver 1. Now if I check it, the 1 is delivered. So when I call this function over here, I can indeed see that order 2 and 3 still needs to be delivered. But there's this extra 0 padding. And you will see this more clearly if we deliver number 3. So deliver number 3, call this again. And now you can see that number 3 was delivered, and we only have the second order left to deliver. But we still have these 0 paddings. And that's what I'm going to get rid of now by making use of a for loop. Keep in mind, like I said before, you can use a for loop for this part and vice versa, or you can make use of just for loops. But let me show you how a for loop works. Firstly, to create a for loop, you start with the keyword for, and then your brackets and your code block. This in the brackets is not fully the condition. This is actually where we specify some parameters as well. So firstly, I'm going to specify a uint and call it j. J will be equal to 0. Then I end this with a semicolon. So essentially what I need to do now is check if j is less than count, the count that we have specified up here. After this condition, I'm going to end it again, and then simply say j++ to do the incremental part that we have done over here for the while loop. So as you can see, a for loop encapsulates everything it needs in these 2 brackets. So with that set in place, we can now reduce this temp order array to not have that padding. So essentially what I am going to create is a new array, also memory, and maybe we'll call this results. This will be equal to a new array. And this time for the fixed size, we're going to use count. This is because inside the code block of the for loop, I want to say that the result of j now, because we are at this counter, is going to be equal to the temp orders j. And that way, we are essentially reducing this temp orders. So we are not going to return that, but instead we will return the result. So just to walk you through this so it's more clear, remember result is really empty at this stage, and it only has this identifier for the index. So when it's 0, we are going to put at index 0, it needs to be equal to the temp 0. And because it's only going to take into consideration up until the count, it should eliminate those zeros for us. But let's put it to the test. Let's go and deploy the contract. And now I'm going to just simply create some orders. So let's do again 1, 2, and a third one. We can just verify and see that it's there. If we now check all the orders that needs to be delivered, we can see order 1, 2, and 3. I'm going to deliver number 2. If I call this again, we are left with order 1 and 3 without those zeros. And that is it. You can now use your for loop or a while loop for whatever use case you have. Now keep in mind that loops sometimes are better suited for certain scenarios. And if this was very complex for you to understand, don't worry about it too much, because if you are creating simple smart contracts, you won't need loops. But this is how you can use them. So, thank you for watching, and remember to like and subscribe to this channel.